I will explain how to calculate sprinkler system. Please remember this chart. You can find this chart in NFPA 13. I will explain this chart. This is GPM per square feet in x-axis. In y-axis, you can find area of sprinkler operation. In here, I take ordinary hazard group 2. Hazard group defined by your area fire department or your engineers. Normally, it depends on combustion level. If your building will face very big fire, you can go high hazard zones. If you are building like school, supermarket, likewise it is in ordinary hazard group 2. Okay. Before sprinkler calculation, you must identify what is most remote area. This is the building, and the most remote area is this. This is last floor, more remote area, and think this is the floor plan in most remote area. I draw schematic. Think there are some rooms. These are rooms, and this chart you can select what area you must select for most remote area. This is ordinary hazard group 2, and highest GPM per square feet point. This is the point. Please try to find this chart in NFPA 13, and I select this point, and minimum square feet and maximum flow rate density in here. Selected point. So you have to and think there is our sprinkler riser. This is our sprinkler riser. You know, as it is sprinkler riser, come down, and there is fire pump, and this is the sump, fire sump, and this is the most remote level, most remote area. I will highlight it. Think some area. This area must be 1500 square feet. Okay. If there are fire propagate, if there are some fire propagate, think there are some fire propagate, your sprinklers in this area must be activated, and your pump have capacity to supply that flow rate. Please remember that. Okay. Now I will explain how we position our sprinklers in this area. How we position our sprinklers. That is the most important part normally in sprinkler calculation. Okay, these black dots are sprinklers. Think. Initially, we define what is spacings with our sprinklers. There is a sprinkler. There is another sprinkler. There is another sprinkler. And sprinkler. This sprinkler distance spacing. Spacing. I take one side dimension. It must be assumed. I take 3 meter. But please remember, this selected value must be lower than 4.6. This value must be lower than 4.6 meter. It is defined in NFPA 13. NFPA 13, you can find this value. Okay. And I will explain what is one sprinkler operation area. One sprinkler operation area. Think this is 3 meter and think this is the x meter. X meter. Then your sprinkler, one sprinkler operation area is this. If I draw center line, this is 1.5 meter. There are 1.5 meter. This is x bedima 2. There is x bedima 2. Okay. This is the basic before you go high level calculations. Okay. In here, I select 3 meter. You can select 4 meter, 4.2, 4.5, 4.6. You can't select 4.7. Okay. Now I want to, this is first, I put number 1. I will go for number 2. Number 2, we have to find number of sprinkler per branch. Okay. How we can calculate number of sprinkler per branch? According to NFPA, number of sprinkler per branch equal 1.2 square root 1500. This is the minimum maximum sprinkler operation area, protection area. Actually it is a protection area, this area, divided by sprinkler spacing. Sprinkler spacing. I convert it to square meter. It is 139. So I calculate 1.2 multiplied by 39 square root divided by spacing is 3. Now I get 4.72. Assume 5. We can position maximum 5 sprinkler per branch. I will explain what is the branch. Then this is the riser, main riser. Then now sprinkler pipeline come and they supply these sprinklers by branch line like this. We position sprinklers there. This is one branch. One branch. In this branch line, if think this is the branch line, you can position maximum 5. 1, 2, 3, 4, 5. You can't position 6. Okay, I think you understand it. If you can't understand this, you can ask questions. Okay. Maximum is spring per branch. Okay. Now we can go number 3 step. Number 3. Now here I position I put 4 is sprinkler per branch. I put 4 sprinkler per branch. This is my sprinkler line. I put 4. 1, 2, 3, 4. Their spacing is 3 meter. Now I draw protection area. I think it is the protection area. 1500 area. This area is 1500. Area. Now there is this to this 1.5 meter, and here to here also 1.5 meter. In here to this distance are 3 meters. This distance are 3 meters. 3 meter, 3 meter, 3 meter. Now this length. Now this length is 39.37 square feet. You can convert, this is meters. Now you can convert to square feet. Now I find width. This length. This is L length. I want to find L. L equal 1500. This simple equation you all know. Divided by 39.37. Now L is 38.1 feet. This is 38.1 feet. Okay. Now I want to find what is, I have to position sprinklers in this whole area. So I want to find what is the spacing. In here, this is X. So I want to find this X. I put the sprinkler here. Now I don't know what is the distance here. The X meter. How can I find it? This is 38.1. So X meter equal 38.1 divided by 3 equal 12.7 feet. What is tree? Tree. I think all of you are confused. What is tree? I assume it. You can assume 3, 4, 5, 6, 8, 9, any number. But here I assume 3. Why I assume 3? Sprinkler to sprinkler, maximum space must be 15 feet. Must be 15 feet. If you assume 2, it is near 19 feet. So it is higher than 15 feet. I assume 3. So it is 12.7 feet. Now I position this. This is okay. This branch. Sorry, this is the branch lines. The X is 12.7 meter, and here to here 12.7, and here to here is 12.7 divided by 2, and here to here also 12.7 divided by 2. In here to here 3 divided by 2, it is 1.5 meter. Okay. So now it is fourth step. one sprinkler operation area. It is this. I take yellow color. This area. This one is sprinkler operation area. It is 3 meter equal here to here 3 meter and here to here 12.7 meter. Now 12.7 not meter, feet. These are feet. Please convert this value to meters, and here meters and there is feet. Now 3 meter equal 9.84 feet. So one sprinkler operation area equal feet 9.84 multiplied by 12.7 is equal 124 square feet. Now step 5. Step 5 is we have to find one sprinkler discharge Q equal, this is 0.2 GPM per square feet, 0.2 multiplied by 124 equal 24.8 GPM. Okay, this is the one sprinkler flow rate. Actually, it is not one sprinkler, it is a most remote sprinkler operation flow rate. Most remote sprinkler. This is the most remote sprinkler. It is position situation in largest distance from fire pump. Now you have to find K factor of your most remote sprinkler. Number 6. Find K factor. You know sprinkler equation K equal Q flow rate divided by square root P. Now your Q is 24.8 and minimum residual pressure is 20 psi. pm psi. This is question. I will tell you. Minimum, according to NFPA 13, minimum operation pressure of most remote area of ordinary hazard group is 20 psi. This is this value, 20 psi. Now your K value is 5.54 GPM per square root psi. Okay, but in industry you can find K factor 5.6, sorry, 5.6 sprinklers. This is the way to position your sprinklers. Now you can pipe size according to NFPA 13. If your sprinklers 2 sprinklers, you can go 1 inch pipe size. This is inch. You can position here 1. There's 2 sprinklers, also 1. If sprinklers are 3, you can go 1 4 pipe size. There are sprinklers are 12 and your main pipeline size is 12 now. If 12 to 40, and you can go your pipe size with this inch pipe size. But remember, normally according to BSI, most remote area, this is most remote area, to pump line friction loss, pump line to friction loss must be below 0.5 bar. Most remote area to pump friction loss must be below 0.5 bar. Please remember only friction loss, not head loss. Okay. Thank you for watch this video. I think you understand well sprinkler calculations. If you have any question, ask. Thank you.